Well, right on time, 4 o'clock. Why not do it strict? So, okay, the seventh edition of GSConf, I think last session today, it's a talk about security and JavaScript. I first would like to thank, I started GSConf in 2014, and then I got some help from Jill and Olivier at West, and now this year Shane and Jean took over, so my eternal gratitude to all of them to continue the tradition. So nice to be here. I think all speakers, they already had a talk today, so but perhaps you can still shortly introduce yourself because I don't think everybody followed every session. So I think Matias, very short.
Sure, absolutely. Very nice to meet you. I'm Matias Madou. I'm the CTO and co-founder of Secure Code Warrior. I'm Belgian. Started my career at Ghent University, pursued a PhD in application security, moved to the US to Silicon Valley. So I know Santa Barbara or south of California. I visit that quite often, a very lovely place. In the US, what I was doing, I was working on static analysis solutions, finding problems in code, and I thought it was all too easy to find problems in code if you never tell a developer how to write secure code in the first place. So with that knowledge, we started Secure Code Warrior, and our ambition, our aim is if you want to write secure code from the start, you should think about us in terms of tooling, in terms of training, to help you in writing secure code. So not in a consulting capacity, but really in the tools and everything surrounding the developer in his environment to write secure code from the start.
Okay, Tom?
Yeah, hi everyone. I'm Tom van Kutsen, also Belgian, and my story with JavaScript started roughly 10 years ago while I just wrapped up my PhD in programming languages at Brussels University. And then got the opportunity to join Google for a while and work with them on their secure subset of JavaScript called Caja. And through that collaboration, also spent some years on ECMA TC39, the standards committee, and helping shape ECMAScript 2015 or ES6 as it was called back in the day. The last few years, I've stepped out of academia, went to industry. I'm part of Bell Labs, which is the research division of Nokia. So doing lots of stuff. And whenever I see an opportunity to pitch JavaScript, I will do that. So, okay.
Okay, Tim?
Hi, I'm Tim Doherty. I am originally British. I grew up in England, still hold a British passport. I was born in Zambia. I spent a few years in Canada, a few years in Maui. Kind of have been a bit of a traveler around and about. These days I live in Santa Barbara, California, and I work for Procore Technologies, which is a cloud-based construction software company. And while that doesn't sound super interesting, it's actually quite fascinating. Construction, at least in the US, is the second least served industry by technology behind agriculture and hunting. So it's ripe for disruption, and Procore stands to lock up that vertical. I have had a kind of a really interesting career, worn a bunch of different hats from developer to owner of a small LLC, director of software development. These days, I'm an architect focused primarily on front end after having made the leap about 10 years ago from back end server side and thick client development. And I often fill that role of the one really senior IC at the table in architecture discussions representing the concerns of the front end. I also have the opportunity as a point person on most of our repositories to catch security issues as they're introduced in PRs. And then one of my main thrusts as an IC is to be a mentor for people. I had people that mentored me coming up, and without that, my career trajectory would have been quite different. So it's not enough just to tell people that they've done something that's not great. You have to educate them on why and help them prevent doing it in the future. So that's like a core principle of mine.
Okay, last but not least, Forbes Lindsay.
Hi, well, hopefully my internet holds up because I had a few issues when I was joining. But I'm Forbes. I'm based in the UK. I've been working on JavaScript for 7 or 8 years now, all kind of Node.js and React, and in the early days a few other things. I guess I became really interested in security a few years ago starting to just look at how so many of the frameworks we use and libraries we use are just insecure by default, and that really frustrates me. I think it's something where I think the education bit piece and how we teach people about security is certainly important. But I guess where I've come from is this question of why do we have to teach new developers about SQL injection? Why do we have to teach them about cross-site request forgery? All of these things can be things of the past if the kind of key open source maintainers understand them and prevent them, rather than being something that everyone has to learn about. So I think that's kind of my interest, and out of that, I've started a couple of big open source projects at databases and at authentication that aim to kind of create more libraries that are secure by default rather than just having the capability of being used securely.
All right. So they asked me to do like some real down-to-earth stuff here, and I thought Tim did some real good stuff. But I'm working at NowJobs. We have like an app and a server. They both run on TypeScript completely. The server does connect to a SQL database, MySQL. So we had these bounty hunters for the moment that we hired, and they're trying to make the system crash and to dissolve, to see what is in it and try to break it. So we got like I think 6 or 7 hits, which we had to pay out because we promised them money if they found something. But everything we found was like typically server side. It has my experience nothing to do with JavaScript, nothing with the app side being totally written in TypeScript actually. So am I correct? Is this just like a typical client server setup where you have to protect your server? Any thoughts on that? So because everything I had to fix until now in the recent 2 months are only like server side hacks they pull off.
If I can start, so actually I would tie it back to what you just said, Forbes. I really think like, hey, if we can make secure libraries, if we can embed security from the start, I think we can make a huge step forward. So I'm not sure, I do not know the exact details of the hacks that you found. But if we start with making secure components and if we embed as many secure components as possible, I think we go a very long way. I think we go a very, very long way in making secure applications. Then the approach that you've taken, which is white hat hackers, it tends to be, what a lot of people initially do. You try to find a couple of these problems and then you throw some tools against it to find more of the same problems and see if you can, again, back to Forbes, if you can fix it in one way with a more secure library or, one thing that can fix multiple problems into your application. So is it mainly server side? I think, well, that's where the money is. I think your database, the bits that really contain the money are sitting server side. So I'm not surprised you put a huge focus on server side problems. And the people that come up with the good hacks or the hacks that go server side, which close to the database, maybe they had your database. I don't know. So the closer to the business value, the more money they can make. So I'm not surprised.
So you mentioned TypeScript running on both the client and the server. Are there any client-side frameworks in the mix?
We're using Angular and Ionic for the app.
Okay. So ironically, Angular is one of the better frameworks out there. Their security record is better than most. They currently have 0 open vulnerabilities, and their time to respond is pretty quick. There's lots of other things to criticize Angular about. I was in the Angular world for a good 5-6 years, and I have a love-hate relationship with the original version of Angular. But one thing that they have done fairly well is mitigate security consequences. That said, there are loopholes in client side that can perpetrate attacks on the server. And so, things like a successful cross-site forgery request can then, because you're forging the credentials of a user, even with proper security mitigations in place, if the server thinks that that's an authenticated user, things can happen. So it is really important to protect against attack vectors on the client as well.
Yeah, I think I would say on that there's a very sort of set list of common client-side issues, and it feels like the server-side space is much more kind of unbounded. Really, at the client side, it's either going to be cross-site scripting or cross-site request forgery, and that covers like 95% of all possible client-side vulnerabilities. And the cross-site request forgery is very much something that either your app has cross-site request forgery protection or it doesn't. And I've not seen many people mess it up in a way where they kind of protect some endpoints and not others. I know it's possible, but on the whole, either you've put that in as middleware on your server or you haven't. And then the kind of cross-site scripting, it really does just depend on framework use. I think when people don't use frameworks, you have to be really careful. And if you do use a framework, as long as your framework is doing a good job with this, it's reasonably easy. I really like React's approach to this in particular, where there is an escape hatch, and the escape hatch starts with the word dangerously. And I think that's like more people need to do that. Like let's have more of this, like, do not use this, it's really dangerous, super long method names for things that are these escape hatches.
Yeah, kind of echoing on cross-site request forgery, it's actually fallen off the OWASP top 10 as of the most recent edition in 2017. And also like CVE reports for CSRF seem to be dropping as well, which means either it's not being exploited or we may just be in a plateau. But I think I agree that it is really
yeah. It's something that surprises me, and I think it's certainly something I see a lot when I look at Node.js applications. Like a huge percentage of Node.js applications seem to be vulnerable to cross-site request forgery because the default cookie library that most people use has no built-in protection, and I think is set to lax mode by default as well. And there is no Express and Koa and what have you. None of them do cross-site request forgery protection out of the box, which is something, like I say, I find extremely frustrating that we don't fix these things.
Tom, you have anything on your mind?
No, I think so. One other dimension that I primarily covered in my talk is when you have to deal with third-party JavaScript in applications, and that is actually happening more and more. So, for instance, imagine that you want to allow users to, let's say you have a spreadsheet and you want them to introduce some formula, you decide to open up JavaScript as an expression language or these kind of things. So then you're really inviting the user to sort of inject code into your web page, and then these kind of things become even more important. So certainly there's a lot of that. Also, you want to then make sure that the third-party code doesn't sort of run with the same authority as your own code, because browsers use this domain-based security policy. So there, I do think on client side that you will run into security issues if you have those kind of scenarios. And so my talk primarily talked about sort of sandboxing mechanisms to be able to sort of sandbox that JavaScript code, make sure that it cannot run amok and destroy the host's environment, essentially. And then, server side. So one other interesting attack vector that I covered in my talk is sort of this. The fact that Node.js and modules, when you install them through NPM, can actually execute code on the server side, even at install time. And people have actually exploited that in the past. I believe the most widely known one is the one where a Bitcoin wallet got hacked because of some obscure, or not an obscure, just a inconspicuous looking JavaScript package called subverted by a new contributor, and they just injected some code that now got executed when someone did an npm install of the package. So that is actually interesting, because you're not even talking about security of your web app, you're talking about the security of your development setup, and the fact that sort of vulnerabilities may come in through your supply chain in some sense, right? So just the stuff you depend on. So that's a new thing that web developers or backend developers actually need to take into account.
Yeah,
I like that idea of running third-party code. I think we're probably going to see an explosion of that. There's a new technology in Webpack that Johan Coppieters announced at JS Nation last week. I'm actually using it as part of a foundation for a micro front-end architecture, which is module federation. And it's basically like a refinement and enhancement of chunk loading operations for lazy loading scripts and their externals concept, which allows you to use a module that's already been loaded, that's already available on the page. But the difference between that and other micro front-end approaches is by a module federation, you can import dynamically a module from any bundle or distributed system at runtime, and it'll run in your application context. So now more than ever, that idea of sandboxing, probably starts with like ES 2015 proxies, like a revocable proxy, and other techniques is going to be increasingly important. Also, I think setting a strict content security policy to only trust domains that you control and know for module inputs at runtime.
All right. Some other stuff that came up, which I looked at your talks, and that you say, yes, protecting while we display content because there can be script text in there and stuff like that. Is what happened. Marketing asked us if they got the names of if they could get the names of our client. We exported them, and they started using them to do some digging on it and some analyzing. And in the end, they opened up a security hole because somebody inserted the script tag in a name, and then our system was totally protected. But then marketing used some PHP scripts to do stuff, and then at a certain point they executed it. So, yeah, then you think you're secure. So, and then what now? You can't even export your data, or?
I mean, I think it comes down to, again, needing to make sure that that it's at the tool level, the tooling level, the library level that we tackle these things. Marketing should not have access to raw PHP scripts that could end up accidentally executing script tags. If they need some kind of coding environment, sure, but like let's get them using something that actually escapes HTML by default or escapes these things by default.
Yeah, but they use Excel and whatever you want.
Sure, but I mean, Excel doesn't execute JavaScript out of the box, to my knowledge.
Well, you can run VB scripts, right, or VBA, basically for application macros, and you can actually do a fair amount of damage with that.
Yeah, true.
It is the truth that we tend to have a lot more developers in our organization. They're not only in development. They're spread out. Somebody in marketing has a little bit of technical chops and is using it, to do the best for the company. They do not think about security. They want to make their own job easier. They wrote a couple of scripts. So there's no malicious intent here. What we've done right now is we try to centralize all the development. So in marketing, just as what Forbes was saying is, hey, you know what? We try to expose the data that marketing needs, and we try to do that in a secure way, so that they do not have to write the scripts. If they need to write a script, they actually have to ask the engineers. Yes, there's a level of overhead here because we all know sales engineers, they can code too. So, and they will code and they will try out new technology. But, we're trying to bring that as close as possible to engineering. Even, by the way, we have a chunk of product innovation. Even over there, we're like, hey, you know what? You can do product innovation, but once you start coding, you have to pair with development so that they know what you're doing. Because if you're going to start using this for real, they can look at it. By the way, they're always looking for the weakest link. So I think your example is very nice. You're trying to do everything in that one department, and then the other department is trying to do the right things, but they are not trained or they do not have the right tool set, and they look for the weakest link on how to get in.
A big thing here as well is about access levels. So hopefully your marketing team have a read-only copy of the data and not access to the production SQL. Which does limit what they can do. There's still obviously risk. There's as soon as code is executed that's malicious, then a lot of stuff can be lost very quickly. But there's a lot you can do to increase the odds that whatever the attacker's trying will just not quite work or not quite have the impact that they want it to.
One of the approaches in this space, if you have the bandwidth, is to provide those types of end users with, a no-code or low-code solution that you build in-house that allows them to model the process they need without writing the code themselves. and or to provide like a domain-specific language that has security built in, where they have some high-level abstraction. They say, I want to model this business process. I want to extract this data and do something with it. But all the implementation of that is actually controlled and secured behind the scenes, rather than giving them direct access to raw programming.
Yeah, I'd love to see us having more domain-specific languages for that sort of thing. It's a topic for another talk.
We're tackling that right now at Procore. We're actually looking at a platform-level domain-specific language. But we'll see. It's also hard to get right and expensive to get wrong.
Yeah, and we have a very narrowly focused domain-specific language where I cut threads that for doing computation of margin on purchases. So calculating what percentage of each purchase is margin, because that is a whole set of rules. But yeah, I mean, I think one of the engineers on the team did just say, why are we putting all this effort in? Why not just give them JavaScript? And I was like, yeah, no, we're not gonna execute JavaScript written by people who are not software engineers. Never mind the effort of teaching them JavaScript.
Yeah, but sometimes you have to trust other systems. They use, I think, Selligent, and they use Salesforce in-house, so we have to export data, and then you never know what happens afterwards.
That's the problem of, like, once you export data out of a system, then what happens sort of in subsequent systems is, that's sort of completely out of your control, right? So, which is why we tend to build systems that sort of wrap around the database rather than sort of shipping data out. But yeah, sometimes you can't avoid it.
Isn't that a normal way of, you try something, and I'm sure, sorry, Johan, I'm not sure where the tool is, but I think it goes through a cycle. You start something and you try the market and you see if there's really a market for your tool, and you do not care about security at that point in time. You just want to find product market fit, and oh wow, it works, and you do some more thing, and oh, you found a marketing person, and that marketing team grows and they want to do the right thing, and then suddenly you realize, oh, they cannot write code, so we have to take that in-house. And I think every step of that cycle of making a product involves risk, and it's always a different risk. And I think right now the risk at the stage where you are is that everybody is having access to that piece of data and they all can write code, and now you have to converge to a new norm, which is, hey, no, the data is sanitized. You're working on a copy of the data. We're going to expose that data to you in line with GDPR, in line with all the regulation. And this is what you can do with the data. And I'm pretty confident in the next stage you will, you mature your product, you mature your organization, but for sure you will have a new challenge in the organization, which is security related.
Yeah, security seems like one of those things that there's plenty of, as a company evolves from startup to robust enterprise, there's all sorts of corners that you cut, and all sorts of technical debt you incur just to prove your market position. But security is one that probably people should be a little bit more stringent about from the beginning. Like, okay, skip test-driven development. Don't worry about your code being clean. Don't worry about abstractions. Security building from the start, because at best it might be an embarrassment. At worst, it'll stop your company before it ever gets off the ground.
There is, I think there's a really interesting point here, though, about all of the risks that are faced by a startup. I'd be curious how many startups in, say, the first 6 months fold due to a security flaw versus any other form of failure. I suspect the security flaws kill a very tiny percentage of startups in that really early stage. And obviously, it kind of ramps up over time. The bigger you are, the more of a target you are, and also the later stage you're at, the more chance there is that you're not killed by something else.
And the harder it is to apply a security patch after the fact.
Yeah, I think that is the biggest thing. Is it's much easier to write secure code, I think, than it is to track down security vulnerabilities in secure code. But I think that's something where, if I were as a founder or as a business, I can see how it would be. It seems like a difficult trade-off, and I think that's something that, as maintainers of software and as builders of potentially open source software as well, we have a real responsibility to make sure that trade-off, as much as possible, just doesn't exist.
And quite often, I think it's underestimated. Like 10 plus years ago, when Twitter was taking off, we were actively monitoring that story because Twitter took off and they suddenly had a huge number of people on Twitter, and they had gigantic problems. And then you're like, oh my God, how hard can it be? It's 140 characters. You send 140 characters, and people receive that. Like how and it's mind blowing. But then if you look at the Twitter side, it's like it's enormous, the amount of infrastructure and scalability, because they had to manage so many users, and they went through such a rapid growth, and they really had problems ramping up with their security. So that's really a good example of where you always underestimate the amount of effort it takes for security if you do not build it in from the start.
Sorry.
I'm sorry, go ahead.
There's an aspect there that you touch on, I guess, by bringing up Twitter that we haven't talked about much, which is there's a side of security that is much less technical, and I think much less sort of naturally exciting and less tractable. But in terms of tracking and preventing and reporting abuse of any kind of and as soon as you've got members of the public communicating with each other, you've got a whole nother set of problems that you also have to kind of think about really early on with how do you enable blocking, how do you enable reporting, how do you deal with malicious actors on your platform. And I think a lot of startups leave that much too late in the process as well, because it kind of seems like it from everything I've seen, it seems like it comes up almost immediately once you launch.
And it's a really hard habit to break, I think, for companies, because these were the practices that got them where they are, right? These are this moving fast and breaking things and not worrying about these critical concerns are what enabled them to be successful. And it is often hard to pivot from that. It's really hard to kind of say, all right, now that we're at this scale, now that the stakes are this much higher, like the risk of some sort of an exploit is also exponentially higher, and we've got to shift the way we do things, and that can take some time. It's like a big steamship pivoting, right? You turn the wheel, and it takes a few miles before it pivots, and it's that while you're turning there is where you're potentially really vulnerable.
Mm-hmm.
To make it more down to earth, Tom, you're working used to work at least with smaller devices too in your company. And we all talk about libraries making our lives secure and encrypting everything. But I also work for a home automation company, and I see that lots of this stuff just passes through the internet or through the network. Most of this stuff readable. And any way we can solve this in an easy way, because these devices, they have like tiny processors, they run on batteries.
Well, I do have one interesting story when it comes to embedded software development in JavaScript. So there is this company called Moddable, and they are creating a tiny JavaScript engine that actually allows you to just use JavaScript to program, just a microcontroller, really. So I think this is, I mean, some people might think this is weird, like why on earth would you want to program a microcontroller in JavaScript? And my response would be, well, why not, right? I mean, it's a very high level programming language, the event-driven model, it's like a perfect match with the typical interrupt-driven event handling you have to do on these devices. And so the interesting thing about this company, though, is they really took security serious from the start, and really also wanted to have a way to make sure that if multiple modules are being loaded onto these devices, how do we sort of nicely isolate them from each other so that different apps cannot sort of shoot themselves in the foot or interfere with other modules, but also how do you protect the IoT device from the script? Because as you probably all know, with these sort of microcontrollers, it doesn't take much to burn one, does it? So you just have to make I heard one guy give a talk on like a light bulb, for instance. If you constantly put it on max brightness for too long, the thing will burn, right? So you have to sort of protect against that. I think they did a very interesting thing where they wrapped every module in a sandbox, essentially, allowing them to really sort of introduce very simple access control policies. Like, for instance, with the light bulb, like they just they expose the API, but they make sure that the user script cannot just do stuff that will break the device, right? So it's a very interesting setup where it's extremely easy for the end user. They can just use JavaScript, but they're not going to be able to shoot themselves in the foot because there's just a tiny layer of access control policy around that. And because it's based on sort of some of the principles I talked about in my talk, this does not require like a huge expensive technology stack with a hypervisor or anything like that. It's like it's a VM that runs bare metal JavaScript, and then all your security policy, all of your isolation is actually happening inside of JavaScript itself. So I think that's an interesting thing. And I'm pretty sure that this will be a successful play in that space, because I think there's like 4 or 5 JavaScript VMs that target embedded devices. So I really think we're going to see more of that in the coming years. But I'm not sure if your question was more to that or more related to the, let's say, encrypting the payload when it travels across the network, because that's, of course, another security concern.
It's protecting the device, 1, and 2, then what it's sending across the network, and it's like the second big thing to protect.
Right, but there I think, the most important thing will be to just use your secure sockets layer, right? That will already prevent a lot of the eavesdropping and man-in-the-middle attacks. So,
Tom, can I ask you something? So if you're talking about that, how does standardization play in there? Like how much of the stuff that you've just mentioned is custom to your devices and what you're trying to achieve, or do you move to standardization? So I'm not aware of anything in that area. So that's
so actually an interesting backstory there is the Moddable folks. They're a company that they're building that lightweight JavaScript engine in house, and in order to provide that isolation, they actually had to introduce a new API, a very lightweight API, but it's called compartments. So it allows you to compartmentalize your let's say your JavaScript heap into separate compartments where there is some form of protection. And they've actually brought that to the standards track. And there's other companies that had similar needs that sort of rallied around that. And that's something that I do see happening a lot in the JavaScript community. So one company making a case for something is going to have a very hard time pushing something into the standard. I think the committee is a bit allergic to that, and it's happened in the past that certain companies wanted to sort of just strategically push stuff into the standard because it fit their roadmap. But if you can sort of argue that your use case is more generic, it's not just about your platform, it actually solves a general need. In this case, sort of sandboxing different JavaScript modules, it actually comes up surprisingly often, whether in sort of client side, when you're dealing with web applications and you have like some third-party widget you want to sandbox, whether it's on the server side, you have some plugin extensions you want to isolate, or whether it's on an embedded device. And so what you see is different companies with similar interests then try to rally behind a proposal, and then that sort of gets iterated on. And of course, what you then do see is the companies that have made a head start in actually implementing and prototyping some of this are, of course, driving that and are often able to sort of get the API through with community feedback, of course. And of course, also taking the more general use case in mind as opposed to the very specifics of their specific use case. But yeah, so in this particular case, this is indeed so these guys actually contributed their APIs into the standards process.
Yeah, that's good. I think that's the way to go, because it's always in corner cases and edge cases or a one-time thing where you find these security holes and security problems. And I'm not advocating the more eyes, the more secure it will be, but more likely the more people that work on it, the more people with knowledge will dig into it and say, hey, is this a good idea? Can we rally around it? Can we make this?
That's absolutely true. That's like Eric Raymond's, given enough eyeballs, all bugs are shallow. And this is something that I certainly experienced in the standards committee. The fact that you have to sort of bring this API forward, discuss it over and over again, not just with like a committee of 30, 40 people that are all very smart, very knowledgeable people looking at this from different angles. And then also a lot of what goes on in TC39 these days is going on in public, like in public GitHub issue trackers, on public mailing lists. And from my own time on the committee, I think I've received the best, let's say, feedback from arbitrary users on public mailing lists coming out of nowhere saying, have you considered this particular case? And then you go back to the drawing board. And so I think the fact that like in the case of JavaScript, I think we can all be very lucky that the people driving the language. Well, first of all, there is not a single benevolent dictator for life, right? So it's much more open, and there is this sort of the meeting minutes, everything is open, so people that are interested, that have a stake, can actually engage with these proposals and provide their feedback. That's really critical.
I mean, amazingly, really, there is just an open mailing list. You can read all of the past discussion going back over 5 years, I think, on ES Discuss, which is the mailing list for the JavaScript Standards Committee. And you can join that mailing list and just send an email. And if you, I mean, I'm not suggesting that people do it spuriously, but it is kind of amazing that we have that as JavaScript developers. This option of, if you think something should be in the language, you can literally email a list that includes Brendan Eich and includes all of the kind of people maintaining the JavaScript engines, and you'll get feedback, and that feedback is often I've witnessed people get some pretty direct feedback. But if it's if you really think you want to push something, it's an option, which is amazing. And by the way, I maintain esdiscuss.org, which is a kind of readable, easily kind of navigable view onto the archive for that mailing list. Yeah, getting back to I guess we've mostly been talking about security on the device, but in terms of security of the network communication, then I think one of the things that most concerns me about the IoT landscape is that a lot of these devices are effectively web servers. We talked earlier about how there's often more security vulnerabilities on the server than there are on the client, or more severe security vulnerabilities. A ton of these IoT devices are effectively spinning up web servers. So we're looking at a situation where pretty soon, a typical family might have 20, 30, 40, 50 web servers running in their house, all of which are like unpatched, unmaintained. Nobody has any expertise on this sort of thing.
Web server. Battery.
Yeah, exactly. So this is a concerning situation. I think I wouldn't position myself as an expert on this, but someone I follow and who's a former colleague of mine, Alec Muffet, has done a lot of work on Tor and kind of exploring use cases for Tor, and I think that's certainly a really interesting area in this space, in that Tor gives you an ability to have, instead of communicating with someone via an IP address and a port number combination, you can communicate with someone via their public key, and it allows really directly secure communication. Because it's designed to route around censorship, it also routes around NATs and any kind of like networking issues pretty effectively. But the core thing that I think makes it interesting for IoT is that as long as your device is capable of generating a public-private key pair, you can generate a unique URL for that device that is cryptographically signed, such that the only way you can talk to that device is if you have that secure long string. But if you have that string, you can communicate with it regardless of what network you're on, regardless of where you are in the world. So I would hope, and I don't know of anybody actually doing this yet, but I think it'd be a really interesting thing to explore, having IoT devices that kind of communicate with the outside world by spinning up an Onion server on Tor.
Yeah. Well, you're reaching there the communication and if you look at these devices, they're like small web servers, and they communicate with the outside world. It's like the same for smaller apps which you develop, web apps which you develop in JavaScript. And then one of our developers wanted to reach a TCP/IP communication. Of course, they can't because it's blocked by the web views due to CORS. But then actually he could just open a WebSocket and he solved everything through the WebSocket. So what about CORS and yeah, does it really matter then?
I mean,
he just opened up a WebSocket and he did all the communication he wanted. So
yeah, I mean, WebSockets are still subject to CORS restrictions, I believe. I can't open a WebSocket to an arbitrary server from a client-side JavaScript application, unless I'm much mistaken. But yeah, it's certainly an interesting thing. I think the other thing in that area that's really interesting and I haven't seen explored in IoT space is things like WebRTC that could potentially allow direct peer-to-peer communication between a device and a web app that wouldn't necessarily have to be kind of served as one or served together.
Yeah, WebSocket is just an upgrade on HTTP. The initial handshake happens over HTTP. So any concerns you would have over an HTTP connection are still valid. So I would think you would absolutely want to ensure that CORS is being enforced. So the initial handshake is only from trusted sources, and then allow the upgrade to take place for the full two-way communication.
we're right here. Can't you open a WebSocket from a web app?
You can, but the initial handshake is HTTP. So
yeah, sure.
Still subject to CORS.
Yeah, so the way that opening a WebSocket works is that the browser makes an HTTP request first, which will obey and that first HTTP request will obey all of the CORS rules. So if you try and open a WebSocket to a domain that is not the domain you're on, then it will initially send the sort of pre-flight check request, see what it gets back in terms of CORS headers, and if it gets all of the sort of go ahead okay from CORS, then it will make the subsequent HTTP request that gets upgraded into a WebSockets connection. So, I mean, what it does allow is sending arbitrary TCP packets once that connection is established and upgraded. So I guess it's conceivable if you had vulnerabilities in your TCP IP stack that might have been harder to exploit in HTTP communication, it could become easier to exploit at a WebSockets layer. But beyond that, I'm not sure it has any real additional security concerns. I think it's been reasonably well thought out.
Yeah, although maybe even a bit too well thought out. I once read an interesting critique on CORS. I think it was from Leuven University, actually, a researcher that sort of mined sort of different CORS policies from websites, because there's so many knobs that you can turn that it turns out that you can very easily shoot yourself in the foot and have like a CORS configuration that you think is safe, but there's always some backdoor that you forgot to close. And I think that's a bit my issue with CORS is ultimately, I mean, there's many valid use cases, obviously, where you do want to have cross-domain communication. I think the root cause of the problem is that when you're loading all sorts of assets and you don't want some of these assets to communicate with at all, or often you don't want them to communicate at all. Like, for instance, some ad you're loading into the web page, you may want an ad to display itself, but you don't want that ad to communicate all sorts of statistics about your users back to some ad network. And I think so the root cause is you want to have that script be sandboxed so that it doesn't even have access to the XML HTTP request object, right? And if it doesn't have access to that object, doesn't even matter what policy is in place. And I think so that's sort of the from where I'm coming from in the security world, or in the JavaScript security world, trying to push this idea of being able to just load pieces of code with much less powers than the default stuff that you get in Node, in web pages. The amount of authority that is given to a script by default is just orders of magnitude too large. If you have ways of containing that, you don't need all of these extraneous mechanisms like CORS, for instance. So.
Okay, we got a question on board. What about security workers? Is there security risks possible? By Philip Huis.
Service workers. Sorry, just before that, I just want to. I'm quickly reading about WebSocket connections just to refresh my memory, and it looks like they don't enforce the CORS restriction, but it's still only possible to connect to a server that actually does the upgrade to WebSocket. So you can only connect to something that is doing WebSocket, which would mean that by then you have enabled the right stuff. And I would hope. I mean, again, this is something. It comes back to that thing of I don't know whether WebSockets libraries have been carefully written, but I would hope that as a library author of a WebSockets library, you would think about this stuff and hopefully guard against it at that stage. But I don't know whether people do and how well they work. But to answer the question about service workers, since I'm already talking, I guess they have some fairly sensible restrictions around a service worker running in a web browser can only control traffic that is starting from the correct origin. It can't bypass any CORS restrictions, and it can also only be served over HTTPS, which prevents any kind of attack whereby a service worker gets served incorrectly over HTTP and then persisted. I think the biggest risk is in general with service workers is that they potentially could allow a temporary breach to become a permanent breach. So the most worrying scenario is if I manually ignore the SSL certificate error once while I'm in a coffee shop, and that coffee shop installs a service worker between me and Facebook, then that coffee shop potentially gets the ability to intercept all traffic in the future. But it would require me to bypass the SSL check, and that can be mitigated by HSTS, if I got the acronym right, the thing that allows you to enforce SSL certificates in the long run.
Tim, your thoughts on?
I don't have a whole lot of experience with service workers. One of the things that I learned early in my career is that the three most important words I know, and that is I don't know. So I'm going to put it I don't know before.
Yeah. Okay. Well, the other question about web servers in my guitars, not going to happen, so you probably don't want to address that one. Okay, if there aren't any other questions from the public or things that some of us forgot.
Well, so there's some comments about SQL query building, which I think are kind of interesting, but they're going back quite a ways, I guess. But yeah, I think around that like it is crazy that our tooling seems to split so much into like either write raw SQL or like use some super high level abstraction. I think this is just to sort of bring it full circle, I guess, and reiterate the point I made at the start. Is just like we can build libraries that don't have these flaws, that don't let you shoot yourself in the foot. And one of the most exciting developments for me in this area is in the last couple of years we've had tag to template literals added to JavaScript, and one of the things they enable, which is really special and didn't exist before, is a way to differentiate between a string that could potentially be a user supplied value and a string that exists in complete form within the actual source code of your application. And this lets you do much safer. Well, effectively, when you're running SQL, if you're running SQL, that's effectively an eval, a form of eval, right? In that you're taking a string and evaluating it. The nice thing about tag template literals is they give you a way of having a safe form of that eval, where you become only willing to eval something that is literally in the code. So that's the approach I take with at databases, which we use at where I work at Threads, which is that it's an SQL database library for Postgres, MySQL, etc., that only accepts tagged template literals. So you cannot pass it a user generated string and have that be interpreted as SQL.
You can use the same technique for cross-site script prevention on the client as well. Although I would recommend not trying to write that whole set of whitelists yourself. I probably would use a library for that. There's another question. What are tips, approaches to try and avoid security vulnerabilities sneaking into your program through dependencies today? I left that one out of my talk, even though it's regularly on the OWASP top 10 using dependencies or components with known vulnerabilities, since it's not specific to JavaScript. But it's huge. One thing I've been really passionate about over my career is managing technical debt effectively. So tech debt's just like financial debt. Borrowing a little lets you go fast when you don't have the capital to do things you otherwise would do. But if you don't consolidate it and make responsible repayments, then you end up paying more interest than capital, and technical debt can actually cripple you. And there's a subtype of technical debt called innovation debt, where you fall behind on the latest tools and practices, and it's really, really easy to drift on your dependencies. But not only do you lose out on the latest and greatest that dependencies offer, you're much more likely to be a victim of a vulnerability on those dependencies. So, most of us these days use NPM or Yarn and the NPM registry. Both of those tools include an audit functionality that will let you know about listed vulnerabilities. And then there's also third-party tools like Snyk and even Dependabot and Renovate that will automatically open PRs on your repos. In general, you just need to stay up to date. Make sure you're running auditing tools on your dependencies regularly. It's not foolproof, but it will help.
I think on that point, though, I think that they are really important and they are really valuable, but in my opinion, we're really doing something wrong with them, which is that it feels like there is a recent trend towards reporting, in certain libraries, reporting almost every bug as a security vulnerability, regardless of its potential for exploit, and without thinking about how libraries are used. So I think this is something that we have to, I don't know exactly what the fix is, but we have to get away from the situation we have at the moment where I think one of these recently was, I think, Acorn, the JavaScript parser that parses JavaScript code, had reported as a security vulnerability that there was a DDoS attack, a denial of service attack possible by giving it carefully crafted JavaScript. Now, given the way that most people are using Acorn, that is not a security vulnerability. It's a performance cost, and yes, there could be very isolated examples where people are using that library and saying, look, our server somehow supports you giving us untrusted JavaScript and we will parse it using Acorn. And in that situation, it's definitely a security vulnerability. But this got reported as a high severity security vulnerability in Acorn that then gets reported as an issue and opened as an issue on every single repository that uses Acorn, even if they use Acorn purely as a dev dependency. So even if Acorn is only used at development time, not even ever exposed to any user input, just doesn't exist at runtime. So I don't know exactly what the solution is there, but I'm in the situation now where I get maybe 40, 50 reports of vulnerable dependencies to one of my open source projects every week. And most of them, 99% of them, when investigated, you find out, okay, yeah, that's never going to affect any users of my application.
Yeah, I actually agree. Like even when selling software, legal people, they do not look into the code. They see a Snyk report and they say vulnerable, and they say nope, can't buy that. You have to fix your code. It's vulnerable. But if you look into the details, there's no way that something like that can be exploited. I think that it's a commercial. A lot of these tools are commercial tools, and they are evaluated in how many things can you find in a library. So the scoring system, how you compare against these different vendors and solutions is, this one can finds 30 problems. This one only finds 20 problems. The 30 problems is going to be better. So let's take the 30 problems. And yes, it's a real problem, but it has definitely to do with how they measure and how people measure these tools and compare against each other.
Yeah, it's completely backwards.
Mm-hmm.
So maybe one thing that I can add when it comes to vulnerabilities sneaking in through your dependencies, although slightly differently, again related to sort of the security hazard of the BitPay wallet, where one package got compromised. So this is sort of more build time. So there is a very practical tool, although it's still very much alpha, but you can always give it a try. It's called Lava Mode. And what that tool will do is actually, when you install it and run it, it will try and put all of your package dependencies into its own sandbox. But in addition, it will also, let's say, list all of the, global objects or all of the, powerful stuff that those package dependencies rely on. And you get all of that in one nice, simple config file. Now, the interesting thing about that is, as your library dependencies evolve over time and you rerun that tool, you will now get a diff, an actionable, visible diff that shows you how your package dependencies are changing in the way that they use certain APIs. And that can actually be, if that tool would have been around a few years ago, that might have actually caused a lot of alarm bells to go off when all of a sudden that package that never had to use any sort of network requests and file access all of a sudden requested network access and file access. So that's a very practical thing that you can try out today.
Yeah. So we should lock in our packages once we install them with npm install.
Well, that's the other thing, right? That's about sort of making sure that any recent changes in packages don't break your application. That's less to do with security and more, I think, with making reproducible builds. But yes, absolutely.
Package lock. Okay.
Yeah.
Well, I wrote down using the right libraries and sandboxing as the main topics that came up, among other things. But the sandboxing seems like a long way to explore still.
Yeah, well, so the sandboxing, the stuff that I talked about, it's very bleeding edge, right? So this is all part of the standards process. But as I mentioned, for a lot of these things, you do find good shim libraries that actually try to allow you to use this stuff today. They often have disclaimers, of course, that things might change, and some of these tools haven't gone through hardened security review. So it's bleeding edge, but sometimes if that's all you've got, it's better than not putting a sandbox around some third-party code. So.
Yeah, the future is exciting. And what all these things. Yeah.
Well, if you look at operating systems, they already got to sandboxing, and now we still need sandboxing in our JavaScript development. So. Yeah. Okay. I see we're up to 2 minutes and 24 seconds, 23 now. So I would like to thank you to participate and explain some stuff to our readers, listeners. And thank you for being at our first virtual conference. It was when I heard Gene and Shane, it was difficult to find participants wanting to pay, but at least they attracted like 75 people, which is nice for a Belgium JavaScript conference. It's like the same number we got the first year, like 7 years ago. So it's a setback, but we'll get there. And hopefully we can meet next year in face-to-face again.
Hopefully.
Sounds
Thank
good.
you for having us.
Absolutely.
Yeah.
Thank you. Thanks for organizing.
Thank you, Johan.
Yo, bye guys.
Bye, everyone.
Thank you. Good chat.
Thanks for tuning in.